All right, ladies and gentlemen, let's get started with today's class. I am opening up my Zoom meeting so that way I can have the whiteboard so that I can start working with this. So today in class, we talked about slope and rate of change. So let me get my whiteboard here. Give it a minute. Okay. And here is my whiteboard. Hopefully this will work. Make sure my audio is on. All right, I think we're rolling. So today in class we talked about slope. Slope, guys, is basically the rate of change. It's also referred to as rate of change, and it mainly deals with an incline. So when an object where you're going up a stair, or when you're going up an escalator, or when you are or when if you skateboard, you have a skateboard ramp. Excuse me. Basically, the slope is that incline, and rate of change is roughly described, if you want to you do it that way, as how much when we go diagonally. Rate of change is how much we're moving in x, which would be this horizontal line, and how much we would be moving in y. And the y, and let me change colors real quick. Y is what we call the rise. So we say y, and we'll say that is the same thing as saying rise. Okay, so rise. Okay, my cursive is not that good, but this is rise. And the x, which is this right here, is what we call the run. Okay, so x is what we call the run. And when we look for the slope or the rate of change, slope is slope is identified with the letter m, and we say that m equals rise over run, which can also be translated into y over x. Okay, so that's one way of determining the slope. Of course, we have the slope formula, which we're going to see in just a little bit. But so you guys have an idea, that's how we work with our rise over run. So I'm actually getting the textbook. That way I can get acclimated. And we started section 2.2, which was rise over run. And I'm actually going to go ahead and start talking about the first example. And the first example says, a skateboard ramp has a rise of 15 inches and a run of 54 inches. What is the slope? Okay, so this is example 1. And let me write that down. Let me write it over here that this is example 1. So example 1. Example 1. And let me erase some of these things. So we have a skateboard, and the problem is telling us that it has rise of 15 inches and a run of 54. Find the slope. So the rise, let me see, blue. So the rise is 15 inches. So we'll say here that y equals 15. And the run is actually 54. So x equals 54. And the formula says that m equals rise over run, y over x. So all we're going to do is just plug in the numbers. And we're going to say, instead of saying m equals rise over run, we say m equals y, which in this case is 15, over x, which in this case is 54, or rise over run. And whenever we're working with rate of change, or whenever we're working with any rate, which is a fraction, we always express them in its simplest form. So that means that I'm going to divide or reduce 15 by 3. And I'm also going to do the same thing with 54. I'm also going to reduce it by 3. And that would mean 15 divided by 3 is 5. And 54 divided by 3 is 18. So that means that our M, or our rise over run, or our slope, equals 5 over 18. And that is pretty much how we work with this. Now, there's also a different, um, the most common way of working with slope is to use the slope formula. Let me just finish writing this so that way you guys can pause the video and look at what I did on the board if you guys have any doubts, right? So again, just plugged in the 15, which was the rise, and the 54, which was the run, and I can divide it if I have a calculator, but in this case, all I did was I simplified the fraction, and m equals 5 over 18. All right, so I'm going to go ahead and erase this, and let's do example number 2. Example number 2, which is on page 82 as well, says, what is the slope of the line passing through the points -1 and 3? Okay, so I want to find the slope of the line passing through the points -1 and 3, -1 and 3, -1 and 3, and 2 and -1, and 2 and -1, 2 and -1. Let me make sure I wrote that correctly, and then we'll get started real quick with this one. Today's video is really short. There really isn't much that we need to do in this class, or for this lesson, excuse me. So just double checking, -1 and +3, and 2 and 1. Awesome. So when we're working with our slope formula, guys, the formula is not new. It's m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. X sub 2 minus x sub 1. So obviously we'll label this one x sub 1, this coordinate right here, x sub 1, and we'll label 3, +3, y sub 1, and we have x sub 2 and y sub 2 and y sub 2. So what we're going to do, guys, is we're simply going to plug in the numbers into our formula, and y sub 2 in this case would be -1, and y sub 1 would be 3, so that would be -1 minus 3 over, or divided by, x sub 2, which is +2, and x sub 1, which is -1. So -1 minus 3 is -4. And 2 minus -1 is +3. So -4/3 would be the slope. So it's very simple. Just plug in the numbers y sub 1, x sub 1, and y sub 1, x sub 2, and y sub 2, and then just simply substitute them in the formula. So y sub 2 in this case would be negative 1, y sub 1 would be 3, x sub 2 would be positive 2, x sub 1 would be negative 1, and you just subtract. Negative 1 minus 3 is the same thing as saying negative 1 plus negative 3, because when you're subtracting, you're adding the opposite. And then 2 minus negative 1, again, when you're subtracting, you're adding the opposite. So that's the same thing as saying 2 plus 1, which equals 3. So that's it for example number 2. Now, before we get to example number 3, I'm going to erase some of these numbers. I'm going to keep the formula. But when we're working with slopes, sometimes we'll get positive slopes, sometimes we'll get negative slopes, sometimes we'll get slopes that are 0, and or vertical lines or horizontal lines, right? So real quick, what I'm gonna do is I'm gonna illustrate this real quick. So if our slope is positive, let's say our slope is positive, usually that means that the graph or the line of the graph is rising. It's going upward. If we have a negative slope, then that means that the graph is decreasing or going downward or falling. I think that's how your book describes it, as falling. If the slope is 0, then that means the graph is horizontal, and it's a horizontal line. That's if the slope equals 0. If the slope is what we call undefined, and undefined is basically when the denominator of a graph is 0. So we'll use a to represent any number, and 0 is the denominator. When we have this, we have a vertical line. And this is what it would look like. This is also called or referred to as an undefined graph. Okay, whenever you have a slope and the denominator is 0, we simply say that the slope is undefined. So again, if the slope is positive, it rises. If the slope is negative, it falls or decreases. If the slope is 0, it's a horizontal line. And if the slope is undefined, which is when the denominator is 0, then it's a vertical line. Now, using or understanding this information, we can work on example number 3, which is what I'm going to do now. Example number 3 is on page 83, if I'm not mistaken, of your textbook. So let's go with that real quick. So this is example number 3. Let me change the color to black. And if we look at example number 3, we have A, B, C, and D. And A gives us the ordered pair of -5 and 1 and 3 and 1. So you know what? Let me just go ahead and type those up. Let me type those up. And that way, if I have them typed, we're good. So 3A is what we would call -5 and 1. Give me 1 second, guys. Let me fix that. All right, right there. So A is -5 and 1. And 3 and 1. 1 second, guys. Let's see if I can solve this little situation real quick. All right, and we should be good now. So A is -5 and 1 and 3 and 1. Let me just come here and write 3 and 1. B would be -6 and 0. So -6 and 0. And 2 and -4. That would be B. C would be -1 and 3 and 5 and 8. So -1 and 3. 5 and 8. Five and 8. And D would be 4 and 6. So D would be 4 and 6. 6 and -4 and I'm sorry, 4 and -1. 4 and -1. 4 and -1. All right. So all we're going to do is we're going to find the slope of each one of these and then determine if that is rise over run, if the slope is positive, if it's negative, or horizontal. If the slope is right, if the slope is positive, it rises. If the slope is negative, it falls. If the slope is 0, it's a horizontal line, and if the slope is undefined, it would be a vertical line. So always remember this, and I'm going to do it once, but just remember that this applies to all. So we're going to say that the first coordinate is x sub 1, y sub 1. Hopefully you guys can distinguish that. And then the other pair, we have x sub 2. And right here we have, let me see that. Let's see if that looks, if I can make that look better. That, there you go. So x sub 2. And the 1 right here would be y sub 2. And that applies to all of them. So all I'm going to do is plug in the numbers for A. So for A, I would say y sub 2 would be 1, or m equals y sub 2, which would be 1, y sub 1, which would be 1 as well, x sub 2, which would be 3, and y sub 1, x sub 1, excuse me, which would be -5. So then you have 1 minus 1, which is 0, and 3 minus -5, which is 8, so that would be 0 over 8, and 0 over 8 equals 0, so that means in this case, if m equals 0, the line is horizontal. The line would be horizontal. Okay, and in the other one, so that would be A. B, we're going to do the same thing. Let's see if I can move this over here and have the extra space. B would be, and I know that sounds redundant, m equals our y sub 2 is -4. Our y sub 1 is 0. Our x sub 2 is 2. our x sub 1 is negative 6, so minus negative 6. And 4, negative 4 minus 0 is negative 4. And 2 minus negative 6 is 8. And then I just reduce that, right? And that would equal to negative 1/2. Now, because in this case the slope is negative, that means that the line is falling. Okay? So it means the line is falling. Because like I was mentioning a couple of minutes ago, if the slope is negative, that means the line is falling. C says you have C, and that would be M equaling the y sub 2, which would be 8, the y sub 1, which would be 3, so 8 minus 3, the x sub 2, which is 5, so x sub 2 is 5, and the x sub 1, which is negative 1. And 8 minus 3 is positive 5, so that'd be 5. And 5 minus negative 1, remember when we're subtracting, we're adding the opposite, so it's the same thing as saying 5 plus 1, which would be 6. And because the slope is positive, that means that this graph would rise. It would be positive. All right, so now we're going to do D. I'm going to erase some of these real quick, and that way we can do our last one. Up, real quick. There you go. Okay. All right, so this is funny. Okay, so D, I'm doing it here because I have the space, is our M is going to be y sub 2, which is negative 1, minus our y sub 1, which is 6, and our x sub 2, which is 4, and our x sub 1, which is also 4. So negative 1 minus 6, again, we're adding the opposite, so that's the same thing as saying negative 1 plus negative 6. This would be negative 7. And 4 minus 4 is 0. So that means that the graph or the slope is undefined. And that means that the graph, and that U just means undefined, is a vertical line. And the graph is a vertical line. And that's it, ladies and gentlemen. That is it for this video. Hopefully this is helpful. The exercises were posted on your LMS in College 1. So until our next class, stay safe, guys. Bye-bye.